Today, we will talk about atomic masses, Avogadro's number, and moles. I am recovering from a rather virulent cold, so my throat is still a little sketchy, but I'll try and keep the coughing to a minimum. I sent you a list of problems to accompany this video. If you need a copy of that, just let me know. But we're going to work through some 16 problems here. And you will need, of course, a periodic table. I'm just using the very simple periodic table because all I need to know for this is atomic masses. So, simpler the better. And you'll want your calculator handy. Now, I'm presuming that you have a scientific calculator which is capable of working in scientific notation. Okay, very good. So, let us begin. Number 1. Calculate the number of atoms in 0.75 moles of iron. Well, Avogadro's number, as you know, is 6.02 times 10 to the 23rd. And that represents a mole. So 1 mole is 6.02 times 10 to the 23rd. Now, that can be 6.02 times 10 to the 23rd of anything. Insects, marbles, tennis balls, doesn't matter. But in this case, we're talking about atoms. So there's that. 1 mole equals that. You know that. So, very simply, if I have 0.75 moles of iron, so 0.75 moles, the abbreviation for mole is MOL, 7.750 moles of iron. I want to find out how many atoms that is. Well, I will use this equivalency because I know, well, that 1 mole of iron will contain 6.02 times 10 to the 23 atoms of iron. So, now I just need to do that math. So, 0.750, enter that, 6.02, e to the 23, there we are, multiply, multiply, boom. So my answer should be, first off, I need 3 significant figures. The calculator gives me 4.515 times 10 to the 23rd, so I will write 4.52 times 10 to the 23rd atoms of iron. There we go. So number of atoms in 7.50 moles of iron would be that. I should point out that the number of atoms in 0.75 moles of anything at all would still be the same number. The fact that we used iron here doesn't make any difference because a mole is that. So 0.750 of a mole is always that. Okay. Number 2. Calculate the number of molecules in 1.058 moles of H2O. You don't say. All right. Well, last time, of course, we calculated atoms in iron because iron's an element, contains atoms. Water, though, is a compound. It contains molecules. But the method will be the same. So let us begin with our 1.058 moles of H2O. I want to convert that to molecules. So I will write 1 mole of H2O down below there. And up top, I will put Avogadro's number, 6.02 times 10 to the 23rd molecules of H2O. I should point out that to save space, I use the Greek letter mu to represent the word molecules. So that just means molecules. So there we are. So 1.058 moles of H2O times Avogadro's number over 1 mole. The moles cancel out. I'm left with molecules of H2O. So let's say 1.058, enter, 6.02, 10 to the 23rd, multiply those. Now my calculator gives me 6.3691. I should have 3 significant figures, so I will round that to 6.37. 6.37 times 10 to the 23rd molecules H2O. There we go. Number 2. All right. Number 3. Now here, we have a slightly different problem. Going from moles to atoms or moles to molecules is pretty straightforward. As noted, the substance we use doesn't really make any difference because we're only counting the number of items. But here, the substance will make a difference because now we're involving mass into this mix. Okay. So once again, a mole is equal to 6.02 times 10 to the 23 whatevers. Some collection of just like you have a dozen eggs, we have a mole of these. Then by definition then, the atomic mass of some substance, such as the atomic mass of beryllium, which is 9.01 atomic mass units, AMUs. So, the atomic mass of some substance is the number of grams in 1 mole of said substance. So if I know the atomic mass of something in grams, then I know that that represents, that number of grams represents 1 mole of that substance. So that's our key bit of info here. Okay, so which contains more molecules, 10.0 grams of oxygen or 50 grams of iodine? Now, before I can determine how many molecules are in the oxygen or the iodine, I need to first find out how many moles 10 grams of oxygen represents. So we will begin there. So I will say 10.0 grams. Now, these are molecules, so that means we're dealing with O2 and likewise I2. So 10 grams, 0.0 grams of O2. Okay? I'm first going to convert that to moles. And I know, because of the atomic mass, that 1 mole of O2 should be equal in grams to the number of, to the atomic mass of O2. And the atomic mass of oxygen is 16, so the atomic mass of O2 would be 32.00 grams of O2. So there we have grams, grams, moles. There we go. So 1 mole of a substance is equal to that substance's atomic mass in grams. So that will give me, my grams will cancel out, that will give me moles, but I'm looking for molecules. So let's extend this one more conversion, because I now know that 1 mole of O2 is 6.02 times 10 to the 23 molecules of O2. So let us do that. So 10.0, 32.00 divide, and 6.02 e to the 23rd times. So that comes out, I should have 3 sig figs, 1.88, there we go, that's it. 1.88 times 10 to the 23rd molecules of O2. So now let's turn our attention to the iodine. 50.0 grams I2. So again, I first want to convert that to moles. So the atomic mass of iodine is 126.90. 126.90. So the atomic mass of I2 will be 2 times that. So the atomic mass of iodine, I2, is 253.8 grams of I2, which is, of course, 1 mole of I2. Atomic mass represents 1 mole. And again, I wish to convert that to molecules so I can pair them with the number of molecules here. And the number of molecules or particles or atoms in a mole is always 6.02 times 10 to the 23. 1 mole, I2. So there we go. Moles will cancel out, grams will cancel out. I'm left with that. So now let's just do the math. 253.8 divide, and 6.02 to the 23rd times. This is a vexing calculator because it displays it off the screen. At any rate, I need 3 significant figures again, so I have 1.18. 1.18 times 10 to, let's just move over there, the 23rd molecules of iodine. So, which contains more molecules, 10 grams of oxygen or 10 grams of iodine? The answer is, oops, I almost misspelled it. Oxygen. Ta-da! Number 4. Okay, now before we looked at moles and we found out how many atoms or molecules were in a mole. Now we're going the other way around. I want to know how many moles of potassium are 7.58 times 10 to the 23 potassium atoms. So I'm just going to do my math just in the other direction. So 7.85 times 10 to the 23 potassium atoms. Now in this case, I want to convert that to moles, and I know that 1 mole of potassium will contain 6.02 times 10 to the 23 atoms of potassium. So if I just do my little math there, 7.85 to the 23rd, 6.02 23rd, and divide those, boom. 3 sig figs, I have 1.303, so the answer will be 1.30 moles of potassium. That's right, it's just that simple. All right. A solution of ammonia and water contains 2.10 times 10 to the 25 water molecules and 8.10 times 10 to the 24 ammonia molecules. How many total hydrogen atoms are in this solution? You don't say. All right. Well, recall that ammonia is NH3 and water is H2O. So 1 ammonia molecule contains 3 hydrogen atoms. 1 water molecule contains 2 hydrogen atoms. So let us begin. I'm start with my ammonia. So if I have 8.10 times 10 to the 24 ammonia molecules, so that's molecules of NH3, I want to convert that. I'm going to find out how many hydrogen atoms are in there. Well, I know based on my formula that there, for each molecule, so 1 molecule of ammonia contains 3 atoms of hydrogen. So this should tell me now how many atoms of hydrogen I have in that many moles of ammonia. Now remember, when you're multiplying the just some number times a number that's in time notation, this number does not affect the power unless this number also has a power, and this doesn't. So this is just going to be 3 times 8.10 times 10 to the 24. And 3 times 8.10, what is that? 2.43? Let me do my calculator. 8.1, enter. 3 times 24, yeah, well. So, let your calculator do the hard work for you. So we're going to say 8.10 e to the 24, enter, 3 times, that comes out to 2.43 times 10 to the 25 atoms hydrogen. So we'll do the same thing with water here. My solution contains 2.10 times 10 to the 25 molecules of water. And I know from my formula that there are 2 atoms of hydrogen in every 1 molecule of H2O. So again, we'll do our math here. 2.10 e to the 25 and multiply that times 2. That comes out to 4.2. I should have 3 sig figs. Yeah, I should point out, the 3 and the 2 don't affect our sig figs because that's a discrete number. That's exactly how many hydrogen atoms are in each molecule. That doesn't affect sig figs. So this comes out to 4.20 times 10 to the 25 atoms of hydrogen. So I want to know how many total hydrogen atoms are, so I just need to add these 2 together, and that will be 6.63. 6.63 times 10 to the 25 atoms of hydrogen. Again, just adding them doesn't change the exponent unless this addition should work out to be a number greater than 10, which means I'd have to move this decimal place. But in this case, it doesn't. It's just 6, 6, and 3. So there's your answer right there. 6.63 times 10 to the 25. Number 6. Determine the mass in grams represented by 2.50 moles of tellurium. All right. So here I'm taking moles and I'm converting them to grams. So 2.50 moles tellurium. What the heck is tellurium? You don't see very often. There it is right there. It's number 52, tellurium. It's an atomic mass of 127.6, so 2.50 moles of tellurium. I'm going to convert that to grams. Well, we now know that 127.6 grams of tellurium is equal to 1 mole of tellurium. So if I just do that calculation, the moles cancel out. I'm left with grams, which is what I want. 2.50, enter, 127.6 times. I need 3 sig figs. I have 319 showing. That'll work out just fine. 319 grams of tellurium. So 2.50 moles of tellurium is 319 grams of tellurium. All right, this is getting pretty dark under there. Let me just get a new sheet of paper here. Make sure everything is still lined up well. Looks like it is. How many moles are represented by 11.5 grams of sodium? All right, well, should be pretty straightforward, right? I'm going to start with 11.5 grams of sodium, and now I'm going to convert it to moles. Well, we know that 1 mole of sodium will be equal in grams to the atomic mass of sodium. What is the atomic mass of sodium? Why, it's 22.99. 22.99 grams of sodium. So I'll just equal that up there. 11.5, 22.99 divide. I have 5.00 times 10 to the minus 1. I should have 3 sig figs, so I'm just going to put 0.500 grams of moles. Oh, sorry, moles. Moles sodium. 5.500 moles of sodium. Not grams, moles. Okay, 0.500 moles of sodium. All right, number 8. How many moles are represented by 11.5 grams of sodium chloride? Well, this should be done in precisely the same way, except I'll be working with a different atomic mass now, won't I? 11.5 grams of sodium chloride. I'm going to convert that to moles, so 1 mole of sodium chloride. So down here, I know that 1 mole of sodium chloride is equal to the atomic mass of sodium chloride. So what is the atomic mass of sodium chloride? Well, sodium has an atomic mass of 22.99 AMUs. Chlorine has an atomic mass of 35.45 AMUs for a grand total of, my calculator do that for me, 0.99, 35.45 plus, pow, 58.44 AMUs. So this is the atomic mass of sodium chloride. So I know that 1 mole of sodium chloride should equal its atomic mass in grams. So this is going to be 58.44 grams of sodium chloride. So I just do that math. Alrighty. 11.5. I'll just swap those around. Oh, hang on. I put 1.5, 11.5. And divide. Boom. That is 0.1967. I should have 3 sig figs, so I'll be 0.197. 0.197 moles of sodium chloride. All right, let's see what's coming up here. Number 9. A pure gold bar is made of 19.55 moles of gold. What is the mass of the bar in grams? Alrighty. Well, 19.55 moles of AU. I just want to convert that to grams. So how many grams of gold are in a mole of gold? Well, we know that in 1 mole of gold, we have the number of grams equal to the atomic mass of gold. The atomic mass of gold is 196.97. 196.97 grams of gold. So that's simply equal to 19.55, 196.97 times. So I get 385.5 3.50.7, I should have 4 sig figs. So my answer will be 3851. 3,851 grams of gold. So 19.5 moles of gold is 3,851 grams of gold. I know what you're thinking. You're thinking, gee, Mr. Burge, I used to think these were tough. They're not tough. They're easy. Here's another ridiculously easy one. Convert 3.5 moles of carbon to grams. So 3.5 moles carbon, convert that to grams. Well, I know that 1 mole of carbon contains 12.01 grams of carbon. So 3.5, 12.01 times 42.0. I should only have 2 sig figs, so 42 grams of carbon. There we go. That's not so tough. Number 11. What is the mass of 0.0050 moles of hydrogen? Alrighty. 0.0050 moles of hydrogen. Hydrogen, you will recall, is diatomic. So we'll be working with H2 here. So 1 mole of H2 is going to be, 2.02 grams of H2. Now, you might be thinking, well, wait a minute. You just asked for the mass. You didn't specifically say grams. Yeah, that's true. But when we're working with moles and atomic masses, we're generally working with grams. And if I wanted some answer other than grams, I would specify. I would say, what is the mass of 0.05 moles of hydrogen in kilograms, or in ounces, or in weight no one uses anymore. Ooh, how about slugs? Yeah, oh yeah, what's the mass of 0.05 moles of hydrogen in slugs? There's a good one for you. But this is all we want here, so 0.0050 2.02 times I should have 3 sig figs, and on my calculator showing 0.0101, so my answer will be 0.010. Remember, that does not count as a sig fig, so 0.0101 moles, sorry, not moles, curses, 0.0101 grams of hydrogen. If this bothers you about the sig figs, then write it this way. Say 1.01 times 10 to the minus 2 grams of H2. Yes, so a very small amount of grams does weigh 0.005 moles of hydrogen. Okay. A balloon contains 0.54 grams of helium gas. How many helium atoms is this? Oh, okay. So here we're going to go from grams to atoms. All right, we can do that. 0.54 grams of helium, that's He. Now, in order to find out atoms, the conversion I have for atoms involves Avogadro's number, which is moles. So what I can say here is that I first want to convert these grams to moles. So I'll say, okay, 1 mole of helium. The atomic mass of helium is 4.00 grams. So this will give me moles of helium. Now, once I have it in moles, I further know that 1 mole of helium is 6.02 times 10 to the 23 atoms of helium. So there we go. Grams will cancel out, moles will cancel out. I'll be left with atoms of helium, which is what I want. So again, let your unit sort of guide your direction there if you're puzzled about which way to go. So let's do the math. 0.54, 4 divide 6.02, 10 to the 23rd times. I should have 2 significant figures. My calculator showing 8.127, so I will write as a final answer 8.1 times 10 to the 22, and that is atoms of helium. There we go. 13. Calculate the number of atoms present in 40.1 grams of calcium carbonate. All right, so let's start with what the heck is calcium carbonate? Calcium carbonate is CaCO3. Carbonate is a polyatomic ion that has a charge of -2. Calcium is just a metal that has a charge of 2. And the atomic mass of calcium, so calcium, let me write this down here, is 40.08. We know the atomic mass of carbon is 12.01, and the atomic mass of oxygen is 16.00. Okay, so there's my calcium carbonate, and I have 40.1 grams of CaCO3. All right, well, I want to find the number of atoms, so first I must convert it to moles. So I know that 1 mole, as do you, of calcium carbonate should be equal in grams to the atomic mass of calcium carbonate. So if calcium has a mass of 40.08, carbon has an atomic mass of 12.01, I have 3 oxygens, so I should be taking 40.08 AMUs, 12.01 AMUs, and 16 times 3. I have 3 of these, remember. So 03 will give me 48.00 AMUs for a grand total of 9, 0, 0, carry the 1. That's 8, 9. Oh, look at that. That's 100.09 AMUs. So the atomic mass of calcium carbonate, 1 mole of calcium carbonate should be 100.09 grams of calcium carbonate. Okay, we're asking for the number of atoms present in 4.01 grams of calcium carbonate. So first what I'm going to do is I'm going to convert this to molecules, because that is a molecule. Technically, I know it's a formula unit. Don't worry about that. That's a molecule. So now that I have the answer in moles, I can do that conversion because I know that 1 mole of calcium carbonate is equal to 6.02 molecules. I'm sorry, 6.02 times 10 to the 23rd molecules of calcium carbonate. Okay, but they're asking for atoms. So let's look at a molecule of calcium carbonate. How many atoms are present there? Well, I have 1 atom, 2 atom, and 3 more atoms. So that looks like 5. There's going to be 5 atoms in every molecule of calcium carbonate. So I will do one more conversion here. I now have it in molecules, so I know that 1 molecule of calcium carbonate is 5 atoms. All right, so there we go. Let's do our calculating here. 40.1, 100.09, oh, curses. Start over. 40.1, 100.09 divide that. 6.02 to the 23rd times that, and 5 times, looks like my answer, 2, how many sig figs do I need? That's exact. 3 sig figs. My calculator shows 1.205, so I will make that 1.21. 1.21 times 10 to the 24 atoms in 40.1 grams of calcium carbonate. So there we go. That was a yeoman problem. Went from grams to moles to molecules to atoms. Determine the mass of 2.25 times 10 to the 22 atoms of carbon. So here we're going to go from the number of atoms to the mass in grams of that many number of atoms of carbon. So 2.25 times 10 to the 22 atoms of carbon. Well, in order for me to get grams, I first need to go through moles. So let's convert this to moles. I know that 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon. And I'm asking for the answer in mass, so I will convert it to a unit of mass, in this case grams, because I know that 1 mole of carbon is equal to 12.01 grams of carbon. This marker's writing rather thicker than I like, so that didn't look much better. Hang on. How about this one? Oh, that's much nicer. Okay. All right, so now it's just a matter of doing the math. So let's do that. 2.25 times 10 to the 22nd. 6.02 times 10 to the 23rd. Divide that. And 12.01, multiply that. Pow! It's like I need 3 sig figs. My calculator is showing 4.488. So my answer will be 4.49 times 10 to the minus 1. Oh, that seems like a low number. Grams of carbon, or 0.449 grams carbon. I guess, half a gram of carbon. That's not too bad. All right. Number 15. What is the mass of 5.0 times 10 to the 9 atoms of neon? Well, that's a pretty small number of atoms, so I'm expecting a very small answer. So again, we'll convert this to a unit of mass. We'll go grams. So we'll start with what we know, 5.0 times 10 to the 9 grams of neon. And let's see, what was I going to do? Something pretty important. Oh yeah, converting it to that. So first we convert it to moles. So 1 mole of neon, I know, is equal to 20.18 grams of neon. 20.18 grams of neon. And I have completely messed this problem up because I wrote grams of neon here when I should have written atoms of neon. So let us begin again. Well, begin again. So 5.0, oh, that writes much better, times 10 to the 9 atoms of neon. Good, 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 much better. I want to convert that to moles, so I know that 1 mole of neon is equal to 6.02 times 10 to the 23 atoms of neon. I'm trying to get this into grams, so I further know that 1 mole of a neon is equal to 20.18 grams of neon. There we go, much better. So now let's do the math. 5e to the 9, enter, 6.02 times 10 to the 23rd, divide, and 20.18 times. So yeah, I was gonna say it's gonna be a pretty small amount. I should have only 2 significant figures. My calculator is showing 1.67, so I will write 1.7 times 10 to the negative 13. To the negative 13 grams of neon, an exceedingly small number of grams. Amount of grams, I should say. No, number of grams. Amount of grams, number of grams. Well, that's a fine number of grams you have there. I believe it's a number of grams. What mass of silver contains the same number of atoms as 10 grams of boron? What a fine question. All right, so let's start with finding out how many atoms are contained in 10 grams of boron. So 10.0 grams of boron. First, I will convert that to moles, so I know that 1 mole of boron is equal to 10.81 grams of boron. What's more is I want to find out how many atoms that is, so I know that 1 mole of boron is 6.02 times 10 to the 23rd atoms of boron. So that comes out to 10.81 divide 6.02 times 10 to the 23 times, I should have 3 sig figs here, so that will be 5.57 times 10 to the 23rd atoms of boron. Sorry, went out of space there. So that's how many atoms of boron I have. So what mass of silver contains that? Well, I'm going to take that number of atoms of silver, so let's go with that. 5.57 times 10 to the 23 atoms of silver. And I will convert that to moles, because I know that 1 mole of silver contains 6.02 times 10 to the 23 atoms of silver. And finally, I convert that to grams, and I will, that'll be 1 mole of silver. The atomic mass of silver is 107.87. 107.87 grams of silver. So, if I work that out, this is actually a little, discuss this for a second. I have the previous value for the number of boron atoms already in my calculator screen, so I can use that to do the calculation. But if you and your friend are doing your homework together and you're comparing problems, and one of you uses the value that's contained in your computer screen and the other one just types it in anew, you will get a different result. And just to see that, let's do it both ways here. So I'm going to use this number I've already got plugged in here. It's right there. And I'm going to take 6.02 times 10 to the 23rd, divide that, and 107.87 times. Okay, I should have 3 significant figures. My calculator screen shows 99.78. So this should be 99.8 grams of silver. Now that was using the value from the previous calculation that was already on my computer, my calculator screen. So let's calculate it just typing in fresh. 5.57 e to the 23rd, 6.02 e to the 23rd, divide, and 107.87 times, well, that comes out to precisely 99.8 grams of silver. So with which method is right, it really, in most cases, the best thing to do is just keep all the values in your calculator until you arrive at the final answer, and then apply your sig figs to that final answer. When you're just dealing with tenths of a gram and whatnot, it's rarely going to make much difference. But just be mindful that if you and your friend are using different calculations in your calculator, you will wind up with slightly different values. You can see the differences there between those two. I assume you can. 99.787 and 99.806. So there we go. But with sig figs, our end result's the same. All right, so I hope that helps, and you'll now be able to tackle all your homework that involves moles and atomic mass and Avogadro's number with relative ease.